Rachel invests $20,000 in an account that earns interest at an annual rate of 4%. Find the future value of her account after 3 years if interest is compounded annually, semi-annually, weekly, or continuously. So this problem, I would do it differently in a Math 154 class using Excel. But for in our class, we're going to be doing this using formula, okay, and a scientific calculator. So for annually, I think it will be better if we use the same formula every time. So write down that formula. The future balance is equal to principal times 1 plus the APR divided by N, and N stand for the number of compounding period per year. Okay, so if it's monthly, you'll be dividing by 12 because there are 12 months in a year. If it's weekly, you'll be dividing by 52 because there are 52 weeks in a year. But for annually, you're really just dividing by 1. Go where?
Let's go eat lunch.
No, not yet. Can you wait?
Yeah.
N times T. And T stands for number of years you're doing this. So let me do A first, okay? So for annually, Rachel starts with $20,000. I'm multiplying this by 1 plus. The APR is 4%. I should write down as 0.04 instead of 4%. And we're dividing by 1, okay? So you really don't have to divide by 1 for annual compounding. And we're doing it for 3 years. So how many years do we have in a 3-year period? That's what that exponent is, okay? So that's A. I'm just going to set it all up, and then I will show you how we can just use the calculator to find all the answers. So B, they're asking for what kind of compounding? Semi-annual. So N is 2 for that one. So look, 1 plus. Divide that annual rate of 4% by 2. So you're going to get 2% there. And how many semi-annual or semi-years do you have in a 3-year period? Well, each year has 2 semi-years, but you're doing it for a 3-year period, so the exponent has to be 6, okay? All right, what's next? C is weekly, okay? You have 52 weeks in a year. So you'll be dividing that annual rate by 52 to convert it into weekly rate. And how many weeks do you have in 3-year period? You want to have to do 52 times 3. Now for continuously, the formula is a little different. For continuously, you will be using A equals principal times e raised to the r t power. So here's D, how to set it up. $20,000 times e raised to the rate of 0.04 times time of 3 years. So let's get the calculator open and type all these in, okay? So here we go. Let me just open up a Desmo Scientific. Okay, so starting with 20,000 times 1 plus 0.04 divided by 1, and I'm raising it to 1 times third power. And I really don't have to, but I'll just keep it the same format. So look, that's the answer for the first one. The second one, I need to divide by 2 for the semi-annual. So that's the answer for number 2. Part 3, part C, we're finding weekly. So that's the answer. And the last one, 20,000 times e raised to the 0.04 times 3. So there's your answer for the last one. So let's round these to the nearest. I don't think they said how much, but like it's money, so let's round to the nearest cents. Okay, let me make these a little bit smaller. Let's put this one down here so that we can write the answers. So here's the answer for the first one. And really practice if you can get these same answers on your calculator, okay? Because on your exam, you want to make sure that you know how to use these calculators. $22,497.28. That's your first answer. Number 2. $22,523 and 25 cents. I will round that up to 25 cents. And lastly, I'm sorry, there's not two more. $22,548.90. Okay, I'm writing these down. And the last number, the compounding continuously, which will have the biggest amount right there. 22,549.94. So remember, the more frequent you compound your money, the bigger the sum that you will have at the end. Okay, so as the compounding period increase, you see our money is getting bigger, right? So that's how you can do number 1. All right, let me do number 2 and 3 in the same video. Number 2, it says Rachel invests $20,000 in an account that earns 4% annual interest, compounded continuously. When will her account be 3 times her initial deposit? Okay, so if she starts with $20,000, what does she want to end up with? 3 times her money, right? 3 times. So she wants to end up with $60,000 at the end instead of $20,000. I got that 60,000 by doing 20,000 times 3. Okay, but let me write down the formula above. The formula for continuous compounding is A equals P times e raised to the RT power, right? So we want the ending balance to be $60,000. Okay, her initial balance is 20,000, so that's your P. And we're raising this, multiplying this by e to the RT power. R is 0.04, but T I do not know because that's what we're trying to find. Like, when will her money be tripled? Okay, so say T for the unknown time T. Okay, we're going to try to solve this equation. Okay, so what do you do to both sides? We're going to divide both sides by 20,000. Okay, when you divide both sides by 20,000, okay, you're going to get 3 on the left side because 60,000 divided by 20,000 is 3. Now, what's the only thing left on the right side? This exponential term. Now, how do you bring that exponent down? Remember ln? Okay, we're going to take natural log of both sides. Let me duplicate this and do the work on the side, okay? So at this point, you have to take natural log of both sides, okay? So if you take natural log of 3, this will equal to natural log of, I'm going to try to squeeze it in because I don't want to write down too much. So you're taking ln of both sides. And what will happen is this 0.04t will come down to the front, okay? 0.04t. And what happened to this ln e? That's just 1. ln e is just 1. So if you multiply this 0.04t by 1, it doesn't really change anything, right? So you can just say that this really cancels out, okay? So you don't really have to write this down anymore, okay? So now, what's the last thing? You divide both sides by 0.04. And this is where you will need a scientific calculator to get the approximation. Because you can't tell, Rachel. You have to wait natural log of 3 divided by 0.04 years to get your money tripled. No, Rachel's not going to like that. So go ahead and type in ln3 divided by 0.04. Rachel will have to wait about 27 years for her money to triple. Okay? So that's how you can solve this exponential equation. Okay? All right, let's do the last one on this practice page. Revenue from sales of digital content by the New York Times doubled over the 6-year period between 2011 and 2017. Sources listed here. Assuming exponential growth of the digital revenue during this period, what was the exponential growth rate? Okay, so it doubled. We don't know what it started from, but it doubled. Okay, so we're gonna go ahead and use the continuous growth model. I'll write this down. Okay, it's the same equation we wrote, right? But let's see. See, like I don't know what the starting amount was, and I don't know what the second amount, the ending amount is. But what we know is that it doubled. So instead of writing A, how about you write it as 2 times the initial amount? That makes sense, right? Let's say just P is the initial amount. But the ending amount, they just said it doubled. So we're going to say 2 times P. Now let's try to solve this, okay? But before I go ahead and solve this, is there anything else they gave me? Oh yeah, they did, right? The time. It took them how long for it to double? 6 years. So that's what T is, right? So T is going to be 6. Let me erase this T and write down 6. Or write it as 2P equals 2P times E raised to the 6R power. Okay, so I just plugged in 6 in here. And instead of writing R6, I just wrote 6R. That's what it is. Okay, now let's solve this for R. Ready? Divide both sides by P. I want to get rid of the P. Then you will get 2 equals E raised to the 6R power. Now what? You need to take natural log of both sides. Look, if you take natural log, this 6R will come down to the front, in front of natural log. And what will happen to this natural log of E? That will just become 1, so you can just cancel that out, okay? So what's left? ln2 equals 6R. And no more natural log of E, okay? Let's solve this. Divide both sides by 6. What's gotta be the rate? Well, rate is natural log of 2 divided by 6. And I think that's the doubling time or doubling rate formula that you guys may have already saw in the previous pages. But if it's doubling rate, then you want to do ln2 divided by how long it took for this to double, which was 6 years. So that is 0.1155. So if I convert it into percent, I will say 11.6% rate. Okay? So that's gotta be the answer for this. That's the exponential growth rate. But refer back to some of these useful formulas for doubling time or doubling rate that we discussed in the previous pages. Okay?